Hello everyone, I hope you're having an amazing day and welcome back to another lesson of organic chemistry. Now in the previous lesson we went over hydrocarbons, what they were, and how to begin naming very basic alkane homologous series chains without any branches or anything too overly complicated. Now if you haven't watched that lesson yet, I strongly urge you to first go back and watch that one, or else this won't make too much sense for you. But yeah, in today's lesson, we are actually going to be going over how to be naming branches, how to be naming hydrocarbons with branches on them, specifically alkanes. Now, I strongly urge you to pay close attention to this lesson because much of the naming conventions surrounding naming branches in this lesson will be applicable to pretty much all of naming throughout organic chemistry. So pay close attention. Now, let's begin. So let's start off with this hydrocarbon here. We can start off by counting the branches to see, counting out the number of carbons on the main chain to see how many, to see how we should name the main part of it. So it has 1, 2, 3, 4, 5, 6 carbons. 6 carbons, that means it is a hexane. So what we do is we begin by writing a hexane. Now, we notice that there is a branch right here. And basically what we do for naming branches is we look at the number of carbon atoms on the branches and we name them corresponding to how we would name basically all other alkanes or all other hydrocarbons or derivatives. So we would have the same kind of a naming structure of, meth, eth. So let me write it here actually. Meth, eth, prop, but, whatever, right? But instead of adding an ane, we add an il at the end to indicate that it is a branch. So here, on the third carbon, we can see that this branch has only one carbon to it, so this would be a methyl branch. So this would be a methyl hexane. Now there is one problem with this naming right here, is that although it is a methyl hexane, we don't actually know where this methyl exists. This branch could exist very much so anywhere, right? This it doesn't tell us if it's on the second carbon or the third or fourth, so we need to make that distinction. We need to see, okay, hey, 1, 2, 3, it is on the third carbon atom of the main chain, so we write 3-methyl hexane, and now we have like all the understanding of what the compound is. Now if we were given only exclusively this name, we can draw what it is. Now, one very important thing you need to know about naming in terms of this number right here is that you always have to make sure that this number is as low as possible. So for what do I mean by that? For example, let's take a look at this. This structure is practically identical to this. It is still a hexane. Let me just check. 1, 2, 3, 4, 5, 6. Right? It's still a hexane, and it still has a methyl group, but methyl branch. Instead, it is on the fourth carbon atom. Now, what we can do is we can begin naming from the other end. We can name on this end, start off here and go the other way. 1, 2, 3, 4, 5, 6, and it would be a 3-methyl hexane, and that's what we want. You always want to keep it the lower version, the lowest one possible. So this is still actually considered a 3-methyl hexane. Always remember that. Now, what would we do if we have multiple branches? Here specifically, multiple branches of the same type. Well, the convention is actually very similar. What you do is you simply just state all the possible positions, all the positions these branches of the same type are. So if we were to look at this, let's see what the longest chain in this hydrocarbon is. So it's here 1, 2, 3, 4, 5, 6, 7. Okay, so this is the longest chain, so this would be the main chain. So this is what we would have at the end. A 7, this would be a heptane. Now we see there is a methyl branch on the third and fourth carbon position. So what we would simply write is 3, 4 methyl heptane, right? And remember the same rule, the same naming, sorry, the same numbering scheme slash rule works in these cases where you have to ensure that they are as low as possible, the numbers. So you wouldn't name them, you wouldn't number them from right to left in this case like you would here. You would do left to right because that's what allows for the lowest possible numbers here. And also just make sure that whenever you're writing out the numbers, it's in ascending order. So you do 3 4, not 4 3. Now, there's still one more distinction we need to make. Since there are two methyls, we have to have a little prefix. We have to add a bit of a prefix to the methyl name to indicate that there are two methyl. Even though it does say right here that there are two positions where it exists, we still have to add it. Here, it would be called a dimethyl. And di would be for when you have two of the same branch. For 3, it would be tri. For 4, it would be tetra. And I believe for 5, it's penta, but don't quote me on that. But I do doubt you'll ever get anything more than a 2 or 3, but just remember them just in case, right? So this would be a 3,4 methyl heptane. Amazing. But what if they are different branch types? So here we have a methyl, and here, what's this? 1 carbon, 2 carbon. Well, that corresponds with eth, and since it's a branch, it would be an ethyl. Okay, so we have a methyl and an ethyl branch. Awesome. Looking at the main chain, just numbering 1, 2, 3, and we don't go this way because just based on just seeing it, we can see that going from left to right reaches their branches first, so these would give us the lower numbers. 1, 2, 3, 4, 5, 6, 7. This is also a heptane, so let's just add heptane to the end. Alright, there is a methyl branch here and an ethyl branch here. Now, one thing you have to remember is that when there are multiple branches of different types, you always order them in alphabetical order. So despite methyl coming first here, despite methyl being in the third position and ethyl being in the fourth position, you write ethyl first because E comes before M in the alphabet. So it would be 4 ethyl, and then you got another dash here, 3 methyl, and then heptane, no dash, between the final branch that you name and then the main chain. So 4 ethyl, 3 methyl heptane. Now please note that if you have, for example, multiple methyl branches, like say you have 2 methyl branches and the second one is somewhere else in this chain, right? You would write dimethyl. Just because it is a dimethyl does not mean you will use this di in the alphabetical ordering convention. The di or tri or tetra or penta or whatever prefix is not accounted for whenever you're doing the alphabetical ordering. So even though this is dimethyl, it would still come after the ethyl. Okay? So just know that. You will always only ever start off with the actual name of how many carbons there are itself, right? So M. Now, if they are on, and one final thing, if they are on the exact same carbon chain, you just simply write the same number twice to indicate that there's multiple of them on the same thing. So in this case here, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is a pentane. And the branches on the third, there are 2 methyl branches actually on the third. So you would write 3, oh, it's a mess up 3, sorry. 3, comma, 3, dash, dimethyl pentane. Beautiful. And yeah, that's pretty much how it goes for naming chains and branches for alkane homologous series. Thank you for listening to this lesson, and remember to check the description for the practice I'll put practice in the description, and I'll put the answers there on the same document. If you have any questions as to how I got to the answers for the questions, leave them down in the comments below, and I'll make sure to check. And if I have the time, I'll try my best to answer to everyone's questions. But yeah, thank you.